Okay, last few examples of the addition rule. This is blood bank catalogs the types of blood given by donors in the last 5 days, and then you select a random person from this list. So find the probability that the donor has type O or type A blood. So the O's are here in the. Oops, sorry about that. The O's are here in the. So the O's are here on this columns. Type A is this column. So these two are going to be mutually exclusive, right? So the probability of being type O or type A is just going to be, this is the formula, the type O plus type A minus the and, right, the intersection. But there's nobody here. These events are mutually exclusive. So it's just the first two parts. So you get 184 divided by the total. And for the type A, it's of course the 164 divided by the total. And you add those, and that's a probability. When they're mutually exclusive, all you do is add them. The third term becomes a 0 because there's nobody there. Now, if there are somebody, like now, find the probability that the donor has type B or is Rh negative. So type B is this column, but Rh negative is this row. So now these 8 here in the middle, those are going to be in the intersection, right? And you can see that if I don't take care of it, I would be counting those 8 twice. So that's the way you do it. So the type B or Rh negative would be the sum of the type B Rh negative, but see, if I do this, the type A I would do, these are non-mutually exclusive, so it would be the 45, right, of type B. You're counting these 8 as part of it, right? Then the Rh negative are the 65, here. But you see, now you're counting these 8 again, right? So you're counting that twice. So that's why you have to subtract it once. That's what the formula says. So this term, the third term, corrects the fact that if all you do is add those 45 and that 65, you'll be counting twice these 8. So this third term corrects that, and you subtract it once to only count them once. And so you just get 102 or 409, and that's. So this is one of those problems where when I like to bring up that the probability of an event is always a number between 0 and 1. And if in an answer students give me a number above 1, I like to say, well, this is a big misunderstanding of what the probability is measuring, because you should not have a number more than 1. And sometimes students don't understand where can you get a number more than 1 if you're finding probabilities. Where this is an example where it could be, right? It could be that the sum of these two terms is more than 1 because you're not applying the formula correctly, and the student might have forgotten to subtract the and part, right? Which makes it now less than 1. So this is an example where it could happen that if you don't use the formula correctly, you might be getting a probability that's more than 1, which means it's wrong. Okay, this is the last video for a session. Have fun doing some probability.